Hello everyone, and welcome to EdSofta. Um, welcome to EdSofta JAMB tutorial live. EdSofta's JAMB tutorial live teaching. Um, so we'll be talking about equilibrium, or better still, chemical equilibrium. EdSofta is a software company that designs solutions for education. So you do JAMB apps, WAEC apps, just apps that have various features that will help you to pass better in your exams. So what is chemical equilibrium? So what is chemical equilibrium? Chemical equilibrium can be defined as a state where there is no observable change in the properties of a system with respect to time. Chemical equilibrium can be defined as a state where there is no observable change in properties of a system with respect to time, where there is no observable change in the properties of a system with respect to time. So there are two types of equilibrium actually. There's static equilibrium and dynamic equilibrium. Then static equilibrium or is the equilibrium where there is no movement occurring again. So you have a seesaw. That's like the most common example. A seesaw where people, as you apply force, you go down, the person goes up, the person applies force, you go down, and you have that movement up and down, up and down. But it now gets to a level where both of you just decide to stop. So nobody can exert force to move anybody up, and nobody can exert. So it's just in a static situation. So most physical equilibrium situations are usually static. So when you have two things go against each other and they have the same force, you see, they just stay at that position. There's no more movement. There's no more movement. Everything is just an equilibrium. When you talk about forces also, and you have two forces acting on a particular place, and both the reaction, so there's no movement. Like when you hear uniform velocity or uniform speed. So it's not as if the chemical reaction is not in equilibrium. It's not as if the chemical reaction is not happening. It's just that both of the reactions are happening at the same time. So we now say there's a dynamic equilibrium. Both situations are happening at the same rate and at the same time. So there's no situation that is faster than the other. So they both cancel themselves out. So reversible reaction is one which can be made to proceed in either direction. So I'll be switching my screen to the board so that we can see it and understand it better. Okay. Okay. So now we are back. So what do we? So a reversible reaction is when you have something like A plus B is going to give us what? A plus B is going to give us C plus D. But if you notice in the middle, you can see the sign that we used. You can see what the sign that we used. This sign means that the reaction can go in whichever direction. It can either go forward or it can go backward. It can go in what? Whichever direction. So it can either go in the forward direction or go in the what? Backward direction. That's why we say we have a forward reaction and a backward reaction. Now, the reason why there's going to be an equilibrium is when the rate of the backward reaction is equal to the rate of the what? Forward reaction. So it's not as if the forward reaction is not happening. The forward reaction is happening and is forming C plus D. But at the same rate at which C plus D is being formed, A plus B also is being what? Formed. So that's where we now say that what? It is a what? Equally, there's a chemical what? Equilibrium. Because the rate at which the both of them are being formed are equal. That's why we say chemical equilibrium is not static, but what? Dynamic. Because there is still reaction happening, but the rate at which that the reaction is happening, it is happening at the same time. So let's move on. Let's move on. Le Chatelier's principle. Le Chatelier's principle states that if a chemical system is in equilibrium and one of the factors involved in the equilibrium is altered, the equilibrium will shift so as to neutralize the effect. So what this guy is saying, Mr. Chateliers, what he's saying is that if there is a change, so when a system gets to equilibrium, a system like the A and B system gets to equilibrium. Now, sometimes you can what can there are some things you can do that what maybe make the fall reaction to happen more. But the moment the fall reaction happens more, equilibrium will have to shift to a new position to get its equilibrium back. So the goal of this reversible reaction is that this reversible reaction is eventually going to get to equilibrium. But there are there are once it gets to equilibrium, there are particular conditions that you can shift, you can push, you can move around to either to make the equilibrium to shift from where it is. So let's say equilibrium was at this point. There are particular conditions that can affect that same equilibrium, and it will no longer be at equilibrium again and it will shift. So sometimes you want more of the reactants. So what do? You can what? You can apply some of these conditions, and these conditions will what? Will cause more of the reactants, and that will make what? Equilibrium to shift to a what? A different position. Do you understand? It will make equilibrium to shift to a different what? Position. Same thing will happen for C and D. There are some things you can what? Change that will make C plus D to also what? Shift to what? Whatever position you want it to what? Shift. So let's continue looking at the slides. So So, factors affecting equilibrium are temperature, pressure, concentration. Factors affecting equilibrium are temperature, pressure, concentration. Factors affecting equilibrium. So, these are the three factors that can affect which way the equilibrium will go. These are the three factors that can affect which way the equilibrium will go. Either the temperature, the pressure, or the concentration. So we are going to be talking about these three and seeing how they affect the what? The equilibrium. So let's move on. Okay. So we have we have let's take the temperature first. Now, for temperature to affect the equilibrium position, the reaction either has to have a positive delta H or a what? A negative delta H. That means it has to either be endothermic or exothermic. Endothermic or exothermic. Now, for exothermic reactions, sorry, let me start with endothermic. For endothermic reactions, if you have a particular reaction, I'm just writing out reactions, I'm not putting any particular reaction, and you say the delta H is positive. Equilibrium, if there's an increase in temperature in an endothermic reaction, if there's an increase in temperature, it will favor the forward reaction. Increase in temperature will favor the forward reaction. Increase in temperature will favor the forward reaction. Will favor the what? The forward what? Reaction. Increase in temperature will favor the forward what? Reaction. Increase in temperature will favor the what? Forward reaction. And vice versa. And vice versa, meaning that what? Decrease in temperature will favor the what? Backward reaction. That is in the what? Endothermic reaction. So in endothermic reaction, what will favor the forward reaction? The what? Increase in temperature will favor the forward reaction and vice versa. Then we have exothermic reaction. Exothermic reaction. This one is what? Where you have A plus B, you have your reversible reaction, and you have what? A negative delta H. A negative what? Delta H. So increase in temperature here will favor the backward reaction, and vice versa. That means decrease in temperature will favor the forward reaction. So increase in temperature will favor that is equilibrium will shift to the what? Equilibrium will shift right, and here equilibrium will shift left. Can you see it? Increase in temperature will favor the forward reaction and vice versa. Equilibrium will shift right, forward reaction, and vice versa. Equilibrium will shift left if there's a decrease in temperature for the endothermic reaction. For the exothermic reaction, if there's an increase in temperature, it will favor the backward reaction, meaning that equilibrium will shift to the left, and vice versa. That's increase in temperature will favor the backward reaction, decrease in temperature will favor the forward reaction, and the equilibrium will have to shift to the right. So forward reaction means equilibrium shifting right, backward reaction means equilibrium shifting where? To the left. So that about the temperature. So let's look at the pressure. So I'll just move to the right so that we can always still come back to it. So pressure. Okay. So pressure. So this now only will only affect an a chemical reaction of gases. Only affects a chemical reaction. So the chemical reaction does not have gases, then pressure is of no use, of no effect. But now, if the chemical reaction has gases, pressure is of effect. So if you have a chemical reaction, A plus B, gas, gas, It has gas, as long as there's a gas, plus D. Now, you now want a situation where you now want, so in this one, if you have something like this, and let's say you have 2A, 1A, and C and D, or let me use an actual equation so that I can explain this better. So let me just pick an actual equation. Okay, so we're back. So let's say we pick an actual equation. Okay, we have an equation like this. That's your NH3 equation. So you have N2, so you have N2, sorry, plus H2 giving us, sorry, giving us NH3. So this we put 3 here, we put 2 here. Now, from Gay-Lussac's law, we know that this, from our mole ratios, you know this is 1:3, ratio 2. But Gay-Lussac's now tells us that this can be 1 volume, 3 volume, and what? 2 volume. And this will be 4 volume, and this will be what? 2 volume. Now, pressure will favor the side with will favor the side with lower volume. An increase in pressure will favor the side with lower volume, and vice versa. Increase in pressure, so you know how to get the volume. The volume is from the mole ratio. Just use the mole ratio, you add it together. So for the reactant sides we have 4 here, for the product side we have 2 here. So increase in pressure will will favor increase in pressure will favor the side with the side with lower volume. Increase in pressure will favor the side with what? Lower volume. While decrease in pressure, and vice versa, while decrease in pressure will favor the side with what? Higher volume. So just from our Bohr's law that say pressure is inversely proportional to volume, that's how it works here. If you increase pressure, the side with lower volume will what? Equilibrium will shift towards that side. So equilibrium will shift towards the right side. If you decrease pressure, equilibrium will shift towards the left side, because that's the side with what? Higher what? Volume. So that's just that about pressure. Then concentration, which is going to be sort of our easiest, because it takes, students might not really don't really understand the sometimes, but concentration is just all about you just, if you increase once the side with lower concentration, if you increase the side with lower concentration, so let's look at this one, 3Fe plus 4H2O, Fe3O4 plus H2. So this is very simple. Concentration is very simple. If you increase the concentration of this, of the increasing the concentration of the reactants. If you increase the concentration of the left hand side, equilibrium will shift to the right and favor the forward reaction. So concentration is straightforward. If you increase the temperature, if you increase the concentration of this side, so you put either you put more iron or you put more water, more equilibrium will shift towards this side and more of this side will be formed. So it will favor the forward reaction. If you also increase the 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 iron 3 oxide, what equilibrium will favor what the backward reaction, and equilibrium will shift towards the left. So that's just that about concentration. So we've looked at concentration. We've also looked at what pressure. We've also looked at what pressure. We've also looked at what pressure. We've looked at temperature. We've looked at what temperature, and we've said how temperature needs, whether the equation, the reaction is endothermic or exothermic. So endothermic means a positive delta H, that's enthalpy. Exothermic means a negative enthalpy. Based on that, you can now what deduce how equilibrium will shift. Based on that, you can now deduce how equilibrium will what shift. So we are going to be looking at some questions now. But before that, let's talk about one person, one last person. That's the equilibrium constant. The equilibrium constant. An equilibrium constant is a measure of the ratio of the equilibrium concentration of the product of a reaction to the equilibrium concentration of the reactants, with the concentration raised to the power corresponding to the coefficient in the balanced reaction equation of the reaction. So let me give an example. Let me interpret what I just said. So imagine you have an equation like this. Now, now, if you are asked, sorry, I almost thought it was mass here. If you are asked, if you are asked to find the equilibrium constant, what do? All you just need to do is say K is equals to C raised to power small c. So these are the reactant, the products, all over A. So this is sorry about that. So this is how you will find the equilibrium constant of an what? Of a what? Of an equation. Now, mind you, if you are given another equation like this, same equation, but this time the states are given. but this time the states are given. So this time the states are given. So so this time the states are given. You would also just do exactly what was here. So all you just have is this, our equation here. So you have, so so you have two solids in this place. So if you are given and you are asked to find K with a subscript P, that's equilibrium constant of pressure and not equilibrium constant of concentration, because what we have here is equilibrium constant of concentration. What you will have, because of the solids one, the solids will round off to 1 because pressure has no effect. And what you just have at the end of the day is d raised to power d, small d, sorry, all over b, sorry, this should be b raised to power small what, b, because this is a solid and this is a what, solid. So this is equilibrium constant pressure. This is equilibrium constant concentration, Kc. Do we all understand? So that is that about the equilibrium constant. So let us just take a look at a few questions and we'll be done for the class. So we'll be using the EdSofta. So the EdSofta app. So this is it starting up. Practice exam. We'll go to practice by topic, and we have chemistry, select topic, we can unselect all, and we go to chemical combination, we click done, and then you can pick the questions, and then we start going through. Oh, sorry, not chemical combination, chemical equilibria. So you can pick that. So this is the chemical equilibria, and then, oh, let me go back, increase number of questions, and then so we begin to look at them. So look at this. Dynamic equilibrium describes a situation where, yes, both the forward and reverse reactions proceed at the same rate. We have looked at that. Both the forward and reverse reaction proceed at the same rate. Now, the equilibrium constant K of the reaction above is represented as, yes, so equilibrium constant K, same way we do it now. If you look at it very well, your answer is what? See, now if they ask the equilibrium constant for pressure, if they ask the equilibrium constant for pressure, your answers will just be the H2. You can see there are two answers that have the H2, but because of they didn't ask for that, that's why it's just asked for equilibrium constant. So your answer is this. So we have this. What is the effect of increasing the pressure on the equilibrium reaction? Now you look at it, look at this. This is one, um, this is one, and this is one. That's what? One volume, that's two. This is, and look at this. There are solids in the reaction. The reaction is not a gaseous reaction, so pressure cannot affect the reaction. So there's no effect of pressure because they are what? Solids in this reaction. Look at this thing. What is the effect of precipitating? Precipitating means that you are generating more, you are precipitating Cu2 plus as CuS means that you are removing Cu2 plus from the reaction. And if you are removing this one from the reaction, it means that this side is less favored. It means that this side is less favored. It means that this side of the equation is less favored. That means equilibrium will have to shift to the what? To the what? To the left to favor the what? Backward reaction. And if equilibrium has to favor the backward reaction, that means more NH3 concentrate will be what? Generated. Equilibrium will shift towards the side. So here we have a positive. Now, increase in temperature, like we said in that place, if you can remember vividly, here we said that what? Increase in temperature. We said increase in temperature, sorry. He said increase in temperature will favor the forward reaction in a what? Positive delta H. If we look at our question here, we also have a positive delta H, so it's what? Increase in what? Temperature. In an equilibrium reaction, which of the following indicates the maximum yield of the product will be obtained? Yes, that is when delta H minus delta S is equals to what? 0. Which of the following reaction will an increase in pressure shift the equilibrium position to the left? Now look at this. This is 2 volume. This is low volume. So this one, the answer is N2O4. This is why, because this side has the lesser volume and pressure will what? Will make equilibrium will move towards the side with lesser volume if there's an increase in what? Pressure from the what we discussed earlier. The reaction above can only attain equilibrium if a gaseous reactant is added. Yes. So the reaction has to be in the same phase for an equilibrium to be attained. They have to be in the same phase for an equilibrium to what? Attain. Or better still, it has to be in a closed system. Yes, it has to be in a closed system. In the reaction above, high pressure will favor the forward reaction because this is this side of the reaction is this side of the reaction is has 3 volumes, while this side has 2 volumes. So high pressure and increase in pressure will favor the forward reaction because it has what? Lesser volume. D is the answer because it has lesser volume. So we have looked at a number of questions. We have looked at a number of questions. What you really need to understand for you to solve these questions is to understand how these separate factors affect the equilibrium of your how the separate factors affect the equilibrium of your affect the equilibrium of your program, of your reaction. So once you understand these three, those are the major type of questions that come out. Which would it increase? Would it not increase? If you apply pressure, would it increase? If you increase temperature, would it increase? If you decrease concentration, what will increase? If you increase concentration, what will increase? These are what the things that would come out. And also, how do you find equilibrium constant? These are the major type of questions that come out in JAMB. So it is very, very important for you to digest this information about how temperature affects the reaction, how pressure affects the reaction, and how um, this affects the reaction. So we'll be coming to an end of the tutorial, and this tutorial was brought to you by by EdSofta. EdSofta is a EdSofta is a a Eds is a software solution, education software solution company, and we are doing our best to bring out more apps, better apps that are going to help you pass your exams. So if you want to prepare for your JAMB, you can download our app. You just need a token of 1,500, and with the token of 1,500, you can you can pay. You talking of 1,500, you are able to activate the app, and with that you are able to access all the features of the app that are tailored to helping you pass your exam. So this will be our end. And one last information about chemical equilibrium that I would like to share is that catalysts do not affect the position of the equilibrium. The only thing that they do is that what they increase the rate at which you get to equilibrium point, but they don't affect the equilibrium. So just the same way temperature and pressure and this can affect the position of the equilibrium, catalyst cannot affect the position. And that where the equilibrium will attain position, that is where it will attain position. But catalyst can speed up the rate at which they attain the equilibrium. Thank you very much. Thank you for coming for the tutorial, and God bless you. The biology tutorial will be starting soon in like an about 30 minutes. So please just thank you very much, and God bless you.